We are here today to talk about Scarred Liver Project. The main reason for us to take this on is that death from cirrhosis, as we call it, which is extreme degree of scarring in the liver, has gone up several folds in the last few decades in the United Kingdom. Common causes are excess drinking, excess weight, and chronic hepatitis. The problem with liver disease is that it remains asymptomatic for a long period of time, even up to the point of you getting severe scarring within the liver. And second thing is that if two people are drinking the same amount, one might get scarring, the other one may not. So one might assume that we are all drinking the same amount, so I'm okay. One of the ways to really pick up someone who has got scarring is try and use some sophisticated yet simple non-invasive test to really pick up one who has got already a risk of developing more scarring from the one who doesn't, so that at that stage of early scarring we can intervene and change the natural history of this condition. And at that stage we can actually reverse the problems in the liver, but it's very difficult to reverse or do anything particular once extreme degree of scarring has developed.
We're performing a number of research studies in our biomedical research unit, and my personal interest and the liver group's interest here is diagnostics and finding better tests to assess and diagnose liver fibrosis. And one of the main challenges we have with liver fibrosis is that it doesn't have symptoms until very late on in the disease. And also the current test that we have, the liver biopsy, is firstly only available in specialist centres such as hospitals. It's uncomfortable to the patients. And there are actually issues with the measurement of a liver biopsy because it takes such a small part of the liver. So at Nottingham we're using a variety of diagnostic tests, including blood tests, elastography or fibroscan, and MR imaging. Importantly, we're using those tests at different levels of scarring. So for example, elastography, which looks at how much scarring or how stiff the liver is using physical principles, we're using those machines in a community setting. At Nottingham we've also got an interest in developing MR, and we've used the MR machines to look at not only scarring within the liver, but also something called portal pressure, which is the change of pressure within the liver and the blood vessels leading to the liver. Transient elastography, or fibroscan, believe it or not, was first utilised in the assessment of cheese, to look at the integrity of cheese, and then some bright spark thought of the idea of looking at liver disease with the machine. So this machine uses a very simple concept that as you get scarring in the liver, the physical properties of the liver change. How we utilise that is by creating a wave which is propagated through the liver. And how quickly that wave travels is related to the stiffness and hence the degree of scarring within the liver.
In MRI, what we're doing is we're looking at images based on their water content and how well those water molecules can move around. When we're looking at a healthy liver, then those water molecules can move around really freely, and so what happens is something called the relaxation time is very, very quick, so it's very short relaxation time. When we're looking at a diseased liver, then we have fibrosis, and this means the water molecules can't move around as freely, they're hindered by these barriers, and so this means the relaxation times become a lot longer. So what we can do with MR is we can form maps of relaxation times, and from these maps of relaxation times we can look at stratifying liver disease. So what we have is, with the healthy subjects we have quite short relaxation times, and in those people with liver disease the relaxation times become a lot longer. So the big advantage about MRI is it's a totally non-invasive method of looking at liver disease. So we can look at liver structure with MRI, so for example the relaxation times. But the other thing we can also do with MRI is we can look at blood flow. So we can look at blood flow through the portal vein, we can look at blood flow through the hepatic artery. These are two vessels that feed the liver. And From looking at the different levels of blood flow in these two vessels, we can also stratify liver disease. So we can look at both structure and blood flow and hemodynamics in the liver, all in one scan, all within 1 hour.
The great advantage of the tests that we're trying to develop is firstly, they are not as invasive as, say, putting a needle into the liver. They have the ability to be repeated on regular intervals, which some of the tests currently don't. And that allows us to assess patients in a much more personalised fashion, to tell our patients if their disease is improving, which it can do, or in fact getting worse. And for the development of new drugs in liver disease, it's also important for those investigating those drugs and those monitoring those drugs to have tools that can be used on a regular and serial fashion to see whether the effect of the treatment is beneficial or not.